Hey, this is Mrs. Thompson. We are looking at the second video dealing with arithmetic sequences, but this time we want to look at what's called the recursive formula. I know the notation is new, and I know this is taking us some time, but a recursive formula gives a rule of finding the nth term of a sequence from one or more previous terms. So it's always going to identify that first one. It will then say a to the n is equal to a to the n minus 1 plus 3. What's the plus 3? 3 is a common difference when n is greater than 1. The recursive formula would generate negative 5, and if we think about that, plus 3, negative 2, adding 3 gives us 1, 4, and we could continue. It's an arithmetic sequence because the constant difference between successive terms is 3. So there's a theorem, when we get into geometry next year, you work a lot with theorems, that if d is a constant difference, the following recursive formula generates an arithmetic sequence with the first term a to the 1 and a constant difference d. So anytime you see where it asks you to write recursive, recursive has to have two parts, a to the 1 and a to the n. So what sequence generates this recursive formula? So first off, if we look at this, can we tell what our common difference is? The common difference actually is minus 40. So the sequence is, if we think about it, well, our first term is what I asked you to fill in your notes. And our first term in this one should be 1,000, a to the 1. If we wanted to list the first 5 terms, is what I asked you to do in your notes. The first 5 terms, the first one is 1,000. We're then going to subtract 40, which gives us 960. Subtracting 40 gives us 920. And what I would like you to do is fill in the next 2 terms in the sequence. So if we are looking at the following recursive formula, which one would it generate? Well, if we start off, we know A1 is 24, so right off the bat, we can eliminate C and D. And the nice thing about that is the main reason we know we can eliminate those is that they do not start with 24. Key thing next is we're looking at the common difference is a minus 3. So it cannot be A because A is adding 3. And our answer in this case, if we look at our formula, is that we are going to be subtracting 3 each time. We now want to take a look at the formula for the recursive formula for the following arithmetic sequence. Negative 5, 5, 15, 25, 35. Well, it looks like our common difference, what's happening is our common difference is that we are adding 10 each time. So we want to look through the ones that add 10. It looks like it's going to be A, B, or D. Can't be C. The reason it can't be C is we are minusing 10. It does have the correct first term. Do the rest of them have the correct first term? No. Wrong first term. A1 has to be equal to negative 5. This one had 5. So now we're taking a look, and we want to say, oh, a to the n plus 1 or a to the n minus 1. Well, this cannot happen. So it can't be B, and our answer should be choice D, as you are looking at that, the recursive formula for that one. Here's another example we want to talk about. You borrow $650 for your parents for an airframe division at college. You're interested in attending after high school. You agree to pay your parents back at a rate of $30 a month. Let a to the n be the amount that you owe after n months. So we're going to start this off and put n, and a to the n is the amount that you owe. Complete the table for what we owe each month, then write a recursive formula. Now, we might want to start off as originally we owe them $650. After the first month, we're down to $620. And what I would like you to do right now is to fill in your table so that we have after 2, 3, 4, 5, and 6 months. So continuing where we are going to pay our parents each time, $5.90, and continue this going down. Now remember, for a recursive formula, we need to find our first term, a to the 1. Do we have that? Yes, we do. It is 620. Someone said, what about the 650? Remember, it's the first term, not the 0 term. A to the n, what's happening? Well, we take our n minus 1 term, and then each month we are subtracting a common difference, 30. We're subtracting because we have to owe them 30, and this is always for n greater than 1. This is our recursive formula. We are now asked to take a look at the recursive formula and look at this one. It's kind of like our slope-intercept form. Only thing it tells us our intercept minus 2x. It says where x is the number of terms, y is the value of the term. So what we want to be thinking of is what's our common difference. Now, the first thing you might want to think of, well, what happens when x equals 1? So if we want to think of a table, we have x and y. If x is 1 in this formula, 3 minus 2 gives us 1. If x is 2, 3 minus 4 gives us a negative 1. If it's 3, 3 minus 2 times 3, 3 minus 6, is going to give us a negative 3. So notice the change, negative 2. Where do we need to see that in our formula? If we look at our choices, A, B, C, and D, we're going to notice which one has a change of 2. Well, the only one that has a change of 2 is here, and is our first term. Yes, this has the right first term, but it's adding 3. Adding 3. We're not adding 3 each time, we're subtracting 2. So take a look and see if that makes sense to you. We now want you to look at this arithmetic sequence and write the recursive formula. So again, what I want you to do is I want you to try this one. At this point, you always need to tell me the first term, and then a to the n. Think about what we put next, if you want to look back at the other ones, and try and come up with this formula where n is greater than 1. I'll check it tomorrow in class. Now, this is where it gets a little tricky, and we have to go back to what we knew about slope and y-intercept. It says, write a recursive formula for the this sequence. What we know is the 7th term, so we're going to think of it as an ordered pair, is at negative 45, and the 11th term is at negative 69. Well, one of the first things you have to do when you look at this equation is find the slope. How do we find the slope? We subtract our y's over our x's. Change in y over change in x. So please plug in these numbers. I'm going to pause the video. I would like you to pause the video. And then I'll put the slope up in just a few minutes and we'll continue substituting in and writing an equation. We've now found the slope is negative 6. Once we know that our slope is negative 6, we now want to write an equation. Well, the easiest equation to write is to write it in slope-intercept form. So we want to write an equation, because this is very similar to our recursive formula. So, picking one of our y and x points, and in this case I'm going to use the first one, the 7, negative 45, and I'm going to replace it in my formula, y equals negative 6x plus b, and solve for b. So I am substituting in, and as I do that, I'm putting my y as negative 45 equals negative 6 times 7 plus b. This is a negative 42. Most common mistake some people will do is they will now add negative 45 and 42, but we're actually adding 42 to both sides, which leaves us with our y-intercept, b of negative 3. So I wanted to think of my equation. I could now write my equation at this point as y equals negative 6x minus 3. Now, we still need our first term in the sequence. So, think about if x equals 1. Because when we write our first term in our formula for our recursive formula, then we need to know a to the n minus 1 and what our common difference is. Now, we can already do that part because it is a change in 6. That's our rate of change or our slope. We still need the first term. If x equals 1, y is going to equal negative 6 times 1 minus 3, which means our first term is negative 9. When I look at my formula and it's asking me for the recursive formula, this is what I'm looking for, but I have to have one more thing, and that is when n is greater than 1. Now we want to consider this term. Notice the first one is 53 in our sequence. Then we're taking a to the n minus 1 and subtracting 7. Now, here it says for integers greater or equal to 2. It could have also said for integers greater than 1. So you could have it either way. Describe our sequence in words. If we're going to describe it in words, as you will do in your homework, you would tell me the first term is 53. Each successive term are 7 less than the previous term. Write the first 5 terms of the sequence. I want you to do that for me. I will start you out with 53. Please list the next 5. We'll check it in class. You now look at this one and you think, okay, you have a 201-page paper to write for English. Each night you write 3 pages. I'm sure it's going to take you a while. If you look at this, write a recursive formula that describes the pages left to right after n nights. Now, in this case, if we think about this, our a to the n at 0, we had 201 pages. But after the first night, we're down 3 pages to 198. Second night, we're down to 195. We need our first term. We can't use 201, we have to use 198. Next, we need our nth term. It's equal to a, always to the n minus 1, and then we want to put n greater than 1. And what's happening each time? We're subtracting 3. I hope these are starting to come a little easier, so when we do your homework, they'll make more sense. This is a tougher unit, and you guys are doing a great job, so we'll go through more of it tomorrow.